use the outcome of this simulation to run another simulation on top of it. So in order to run another simulation, we need to first get the outcome of this, which is that mesh that we generate, we simulate. So let's use the item, list item, and from this item, there are multiple things that you can get, but in order to get our mesh, I'm going to use flatten the data, and we get our mesh. Now, if you recall last time that I had was trying to get the mesh, I had very hard time to find it during the item, but using the entwine is helping me to just find it where I'm looking for. Now, let's say that you want to get this mesh and you want to do some other works, like for example, convert this into X surfaces and then do other works on it. So what you have to do is that basically you can use the construct mesh, getting this mesh as an input, and then using the surface grid. So using the surface from the points and connecting the vertices here. Now, if you see the numbers that I got from here is giving me an error because I haven't defined the U value, the correct U value. So I know that when I define this surface, I put that 50 for the value of this surface. So if I put the 51 and connect that into the U value, I will get my surfaces. So if I go back here and then turn off everything else that I have here, so just see the mesh preview off, you see that now I create a surface out of that simulation. So many other things that I want to do with this surface, I can do it right now with this. So most of the time you might work with the surface grids, and then you got the error. Usually you have to do is that you have to check the number of vertices and do the math to see if there is, I mean, if it is a like a prime number, that might be causing a problem or some other issues that you got. Okay, so all right, so we got the surface now. We can use the Weaver bird to give it a thickness. So I'm gonna use the Weaver bird to give it a thickness for this, so mesh surface. And then here I'm going to connect that surface that I have, and for the thickness I can give it a thickness of 2. Probably that's going to do the work for me. All right, so it's a little bit like a less more like a geometry than the surface. Now what I'm going to do is that I'm going to generate a couple of points on top of this surface up here and then drop them all the way on this surface and then see which one of them is hitting, colliding, and then which one of them is just going out of this like a surface. So in order to do that, I'm going to use the populated 2D, and the populated 2D, they have different options. One of the things that we're looking for is the region, which is going to be the rectangle we defined at the beginning. So I'm going to go up here all the way back to this rectangle and using that as an input for the region of this. Actually, not this one, the one that I move. So this rectangle that I move is the one that I'm looking for. So you see that I now populated a couple of points on top of this surface. All right. Now I'm going to use the same tool that I used last time. Basically, I'm going to give surface to, solid point collides. And then this time, my solid will be the surface that I simulate, right? And then give it the thickness here. That's going to be my solid. And the points will be these points that I simulated up. I basically randomly create them. For the true value here, one is in interior. If it is false, the point keep outside the solid. If it is true, it's going inside the solid. And the second one is that when mesh use as an input, it's not only, it's kind of looking at if it's affected by the points that we are hitting them. So either yes or no is like with the result of simulation is kind of showcased how the point's going to affect the surface itself. So for the first value, I'm going to use false because I want to keep them. So I'm going to use the Boolean toggle. I need two of them. And for the first one, I'm going to use false value in order to keep all the elements outside. And for the second one, I'm going to use true because I want to see the like effect of these two points on the surface, right? But these points will be up here. They're not moving. We need to give them like some form of a loads, right? So we're going to use the loads as another goal that we have, and then connecting them to this part. Okay. Now for the load, we can use the same load value that we did last time. So I'm going to give 0.1 on the z direction, and then we are going to reverse that so it's actually going down instead of going up. And that's going to be connected to this part. All right, so we have the value for that. What else we have to have here? It's very similar to the last time, right? We need to make sure that these basically these points is actually colliding with each other as well. So there might be collusion between these points as well. So I'm going to put that here as well. So the sphere collides is basically looking at if these points are colliding with each other or not. So I'm going to give the same connection here, and then we leave all the other values as is. And then here we're going to use another component, which is the ground. So we're going to define a ground underneath the whole things. So when these points are not colliding with the surface, it's going to be hitting the ground and it's not going to go free fall all the way to eternity. So we are going to add this floor from the point goal. I'm going to use the floor and then place it down here. So that's going to be just by itself a component. You don't need to add anything else. It's just going to define that at the end. All right. So all good. Let's merge them and do the simulation again. I'm going to connect the first one here. The second. And the third. And the floor will be connected here. Now we have that. What we need is looking at the bouncy solver. We have bottom to reset, and then we have the Boolean toggle. And then for the iteration, I'm going to use 2. That's going to be reset, and then this part goes to the goal. All right. So let's make that true, and then you see that these points are going to go collide with this surface. And then depending on when, I can just stop the simulation and start it. So these are the points that are in the center of my surface, and there are some points that goes outside the surface itself.